Okay, so we're going to discuss your teacher, Mr. Shande, wasn't able to take your lesson for today, so I'm going to be doing his lesson. Okay. Thank, thank you, Daniel. Thank you, Hamashne. If you need to speak, then you can raise your hand and I'll ask my host to unmute you, or you can type it in the chat. I'm just waiting for my computer. It seems to be circling, and the minute that it finishes, I can go to the first slide. But the topic for today is the rate of dissolving. Okay, so that's our topic, and that is um, okay, that's your normal teacher, and the topic for today is rates of dissolving. I'm sure we'll have a lovely interactive time talking about it. The table of contents, that means that the lesson that we're going to be doing today is first I'm going to define the objectives to you, then I'm going to do an introduction. I'm going to talk about the lesson content, and then I'm going to tell you all about, I'm going to ask you questions while we are going on. I'm not sure why you are glitching, so why I am glitching, but we will continue and we'll see how far we can go. So by the end of this lesson, you would know more about what dissolving is. You'll list and explain the factors of rate of dissolving, then how we'll do an experiment on melting, and we'll also do an experiment on the rate of dissolving. So in a chemical reaction, what you need to know is that the substances are undergoing a reaction, and these substances are called the reactants. While the substances form as a result of the reaction, they are called products. So when you have two reactants together, they basically form a product. Now the reaction rate describes how quickly or slowly the reaction takes place. So how do you know whether a reaction is slow or fast? One way is knowing to see how quickly the reactants are used during the reaction, or how slowly the products, how quickly or basically how slowly the products are formed. So, okay, so what you're going to have to know, the most important things I'm going to show you here are, you have a reaction, and this describes the rate of how quickly or slowly the reaction takes place. Now we also know that we have products. The products are formed as a result of the two reactions that take place. Okay, so we're going to do the rate of dissolving. Now, in a solution, a mixture with a mixture with a liquid where a substance dissolves in a liquid. So basically, you have a solution, and the definition of a solution, if they ask you in a test, they'll ask you what is a solution. So you're going to say that it is a mixture with a liquid where the substance dissolves in the liquid. So this is a test question where they can ask you, what is a solution? You're going to say it is a mixture with a liquid where a substance dissolves in the liquid. Now, when you make a solution, you cannot see the different substances that were mixed. Now, if you look at this experiment at the bottom, I put tiny cubes of sugar at the bottom. You can see it resting here at the bottom, and this is a beaker of water. And now when I stirred the water, the sugar cubes were being distributed throughout the solution. So if you can see, I put a picture here at the top, and this shows you how the microscopic sugar granules were distributed around the beaker at the bottom here. So this circle here is basically a reflection of everything that happens here. And as we continue stirring, then the sugar dissolves and it becomes a sugary solution that we have here. Okay, so when we talk about dissolving, we mean that the particles of the substance spread out evenly through the liquid. Okay, so dissolving basically means that the substances spread out evenly through the liquid. If you want to chat, please can you chat about the information that I have here, but not to each other if you don't mind. Okay, so now if we look at this, this is an example of a solution. We mixed the sugar and the water. So the sugar basically is a solid, the water is a liquid, and after mixing it, which is the second beaker where we dissolved it, we say that by mixing it, we say we dissolving it. So when it is dissolved, we say that now it has become a mixture like this over here. Okay, so you're going to dissolve the sugar solution here, and you call it a starch solution. So the most important things you need to know for this experiment is this is a solution, the one I'm pointing to, and then we have the reactants. The reactants are basically the sugar and the water. And then when we mixed the reactants, it is with the sugar and the water, it becomes a solution and the product becomes a sugar water. So I see that I don't have an annotation bar, so I cannot actually write it down for you. But what you have the reactants, so you can write it down. The reactants are the sugar and the water, and then you get the product. After stirring, the process of mixing the two together is called stirring. After stirring it, you get a product, and the product is basically the solution here, which is a sugar water solution. Okay, I'm going to go to the next slide. So the most important thing that you need to know is when we talk about dissolving, we mean that the particles of the substance are spread out evenly through the liquid. Okay, so if you looked at the picture here over here, these particles, these sugar particles are spread out evenly. Can you see the picture here? It is spread out evenly, so that means that the sugar is dissolving in the whole of this water. So it becomes a sugar solution. Now, what do we need to make a solution? You can write it in the chat. I did tell you in the previous slide what are the things that you need to make a solution. Okay, I see some children, very good, Sharika. You need a solute and a solvent. That's excellent. So there is a child that wants me to go a little bit slower, so I'm going to explain it again. So here in this first beaker, you needed water and you needed sugar. So this water and this sugar is called reactants. Okay, then we applied a process, and the process is called stirring. So we stirred it, and when we stirred it, the sugar granules became evenly distributed around the water. So after it was evenly distributed around the water, it became a product. And the product is called a sugar solution. Okay, so here in the first beaker, we had the sugar and the water, and those are reactants. Then we applied the process of stirring. So we stirred the second beaker, so where the sugar was distributed evenly. And then it formed a product. And this product is called a solution. And the proper name is a sugar solution. So now to make a solution, as the child correctly told me, let's see, what's your name? It was Tresha. I hope I pronounced your name properly, Miss Inkize otherwise. Um, okay, so now the proper definition that you would need to give for dissolves means when the particles of a solute become very evenly dispersed between between those of the solvent. Okay, so dissolving means when the particles of a solute become evenly dispersed between those of the solvent. So the particles of the solute, meaning the sugar, disperses in the solvent, and the solvent is the water. Okay, so now, okay, sorry, Mr. Mkize. Okay, so now we have a solution, and the solution is made up of the solute and the solvent, and when it dissolves, we say it becomes evenly dispersed. Okay, so now I'm going to continue. Now, what are the factors that affect how fast a solute dissolves? Now, this means the rate of dissolving. So it's very important for you to know these three factors because it can come out in your test. In your test, they can ask you first they'll ask you define the term dissolving. Then they will ask you what are the factors that affect how fast a solute dissolves. Okay, so now it is temperature, rate of stirring, and size of particles. So in temperature, the higher the temperature, the faster the solute dissolves. That is, the rate of dissolving increases with temperature. So I want you to remember this. You can write it down as well. Okay, the higher the temperature. Okay, I shall not call you Mr. Mkize. I shall call you Trasher. Oh, I'm so sorry if I did not pronounce your name properly. Okay, so it is the higher the temperature, the faster the solute dissolves. So this is the rate of the lesser. This is the rate of dissolving. The higher the temperature, the faster the solute dissolves. Now, rate of stirring. Okay, the rate of stirring means the faster the mixture is stirred, the faster the solute dissolves. So rate of stirring means the faster the mixture is stirred, the faster the solute dissolves. So I'm going to ask you in the experiments that is prepared for you in the later slides about these three factors. So you need to know about them. Okay, so we have the size of the particles. The smaller the solute particles, the faster the solute dissolves. That means that if you have different types of sugar. For example, you get sugar that you all know, which is the small granules. And then you get sugar cubes, okay, which we hardly see because we normally are used to that finely processed sugar particles. So now these small sugar particles, the solute, they dissolve smaller. So for example, 10 grams of sugar powder dissolves faster than 10 grams of rock sugar. That means that those are the cubes of sugar. So the smaller the solute, the smaller is the size of the particles, the faster it dissolves. Then we have rate of stirring. Rate of stirring basically means the faster the mixture, the faster you stir something, the quicker it dissolves. And temperature, the higher the temperature, the faster it dissolves. So I need you to learn these three really, really well because it will apply to most of the things that you need to learn. Now, you know that we had the phases of matter and you learned it in grade 4, you learned it in grade 5, and now you definitely know it in grade 6 because you did it. And you also learned the processes of matter. So we have a gas. The gas is not in a definite shape. You can see it takes the shape of the container. and it is free to move around. Okay, then we have a liquid. So the liquid also does not have a definite shape, and it takes the shape of the container. But the difference between a liquid and a gas is that the gas particles are far apart and the liquid particles are closer together. And then we have a solid where all the particles are closely packed together and it has a definite shape. Okay, so that's the difference between a solid, a liquid, and a gas. It's the arrangement of the particles, like tightly packed together, loosely packed together, far apart, and then definite shape, no definite shape, no definite shape. So these two take the shape of the container. So this solid, liquid, and gas, if we take water for example, water can be a solid when it is iced. Okay, so this water here, which is a liquid, if we apply the process of freezing, it becomes a solid. If we take the same solid, which is an ice, and if we apply heat to it, then we say that it melts. So if we melt it, then it becomes a liquid again. So now the same liquid here, we can say it's water. If we heat this water further, when it is in its liquid form, it becomes a gas, which is the water vapor. Okay, now this water vapor, if we cool it, that means if we apply, if we cool it basically, these water vapor droplets join together. That means it condenses. So the tiny droplets join together, it condenses, and it becomes water again when it precipitates. Okay, so condenses means that is the cooling of the water vapor. So who would like to tell me what I just said? Is there anybody that would like to raise their hand to tell me what I just said? Okay, you can unmute yourself.
Hello, ma'am.
Hi, how are you?
Fine, thanks, and you, ma'am?
I'm good, thank you. Can you explain to me what I just said?
You said the liquid, which is the water, you put it in the freezing point, and then it becomes a solid, which is the ice. And then if we put it by melting, it becomes the liquid, the water again. And then if we go heat the water further, it becomes evaporation. If we take the liquid, ma'am?
You can continue.
If you take the liquid again and put it by freezing, it becomes the ice. And then if you take the water again and put it by condensation, it means it's joined together and becomes the liquid again.
Okay, very good. So for the when we apply when we this water vapor cools, we say it condenses. Excellent, well done. I think
Thank you,
Treasure,
ma'am.
your hand was. I'm very proud of you. Well done. Treasure, your hand was up. Do you want to tell me? No, George. I can see your hand is up. Can you unmute yourself? I can hear you.
It's Triasham.
Okay, Triash, you can go ahead.
What your meaning is the process of gas, how gas turns into liquid and how solid becomes a liquid. So it's the process between gas, liquid, and solid.
Very, very good.
Yeah.
And now, can you remember in the previous slide I spoke about the 3 factors that affect dissolving? Can you remember what they are?
Mm, factors.
Let's see who can remember what they are. Mallory, you can unmute yourself. Or Lebo.
Yes, ma'am.
You can tell me what's the factors that affect dissolving, the three factors. I did it in the previous slide.
The three factors that affect the rate of dissolving is temperature, rate of stirring, and size of particles.
I am so very proud of you. Well done. Awesome. That is really great. Very good. Well done. Okay,
Thank
so
you,
now I
ma'am.
can move on. Now, what does it take for melting to take place? What do we apply for melting to take place? Okay, Sharika, I can see your answer is correct. Mallory, you can unmute yourself. Oh,
So ma'am, the what is needed for melting to take place for ice to melt is heat.
very good. Well done. Okay, sorry for not pronouncing your name, Shakira, properly. Now I have it. So it's heat. Well done. I'm very proud of you. So
Thank you, ma'am.
melting, you're welcome. Melting is a process that causes a substance to change from a solid to a liquid. Melting occurs when the molecules of a solid speed up through the motion and it overcomes the attraction so that the molecules can move past each other like a liquid. So heat is what causes melting. So when you apply heat to it, we get melting. So now the rate of dissolving, we're going to do 3 investigations. And these investigations, we're going to investigate how temperature affects the rate of dissolving. And we'll do an investigation on how stirring, the amount of stirring, how fast you stir something affects the rate of dissolving. And then the last experiment we'll do is how the size of the grains affects the rate of dissolving. Okay, so now let's look at this investigation with temperature. So you have the thermometer here on the right-hand side, and you can see that the temperature here is a little bit less than about 10 degrees Celsius. And then we have the one that is the high temperature, and it goes up to 90 degrees Celsius. Manori and Habush Hollably Slayer, you can unmute yourself.
Ma'am?
Yes, your hand is raised.
Yes, ma'am. So salt dissolves in hot water faster than it will in cold water.
Okay, because we applying heat to it. Very good. Well done for that. Okay, so we have salt. He knows that salt dissolves in hot water because when I explained earlier, I told you that hot water, when you apply heat to something, it dissolves faster. So let's do this experiment. You can take it down, write all these things down, and you can do this experiment at home. Now, what you need is 3 glasses, or you need 3 glass containers. If you have beakers, that's fine, but if you don't, then 3 glasses are fine. You'll need table salt. Then you'll need very, very hot water. That means you can boil it and then use it after a minute. Okay, then you'll need tap water and you'll need ice water. So these are the different temperatures of the water. One is hot water, one is tap water, and one is ice water. Ice water is water from the fridge. You'll need a spoon. And then what you'll need is a stopwatch. Now, if you don't have a stopwatch, most of you have phones. So on your phone, you have the clock, and on your clock, you have a stopwatch. So you can use that as your stopwatch. And then you can record how fast the how fast the salt dissolved in the hot water, in the tap water, and in the ice water. So the method that you're going to use, you're going to measure the same quantity. Now, when we do an experiment, we must always have the same quantity. So that means that it is fair testing. Okay, so you have the same quantity of tap water, hot water, and ice water. And you have the 3 clear glasses. Okay, try to use the glasses that are all the same size as well. Then you're going to pour 1 teaspoon. Now 1 teaspoon is equal to 5 ml of salt into each glass. Okay, that has the different temperatures of water. And then you're going to stir the solution by moving the teaspoon back and forth through the water. So when you're going to stir it, you're going to use the same method of stirring in all 3 beakers, because that you know is fair testing as well. And then you need to take note of the time it takes for the salt to dissolve completely. So what you can do is you could do the hot water first, and you can stir it back and forth, and then record how quickly the salt has dissolved. You'll know it has dissolved when you don't see the salt anymore. Then write it down. Then you pour the tap water, you put the salt in, you go back and forth, and you record the time of how long it took you. Then do it with the ice water. And then you record the time after you stir it back and forth, you record the time. So what I want to stress is that you must note the quantity, it must be the same. The quantity of water that you're using, 100 ml, you can use a measuring jug to measure it. And the teaspoon that you're using, it must be 5 ml. Okay, so, and when you're using it, use the same amount of salt for all three glasses of water. So you can record the time in the table. So you can draw a table, and in the table you could say hot water, tap water, cold water, and then you could put time, and you can record the time, and you could see which one goes faster. Now you could repeat the steps with the tap water and also with the ice water, and you'll record the time, and then you'll come to the conclusion. You'll ask yourself these questions. So when you're doing an investigation, you'll need the first, when you're doing an investigation, you'll need the materials and the apparatus. Then before even you need that, you need to know the aim of the investigation. Okay, so the aim is to determine the rate at which it dissolves. So I'm teaching you how to become a scientist and how scientists record information. So you have the aim. So after the aim, you'll need the materials and the apparatus. Because you can only conduct an investigation if you have these. If you don't have these, then you'll have to either go out and buy it or make a plan to get them or borrow them from a friend. Then you'll need the method. The method tells you exactly what to do, when to do it, and how to do it. It's just like baking a cake. When you have, in grade 4 and 5 and even 6 in English, you do recipes. And in recipes, they tell you you need the ingredients, you need the method, and you need utensils and stuff like that. And they tell you all these things because before you even start baking a cake, for example, you need to know you have all these ingredients. Because if you start baking a cake and then you mix the butter and the sugar, and after a while you realize, oh my, I don't have baking powder, or oh my, I don't have flour, then you can't bake the cake. So this is why we always have the ingredients, the materials that you need first. Okay? Then the method, it tells you step by step what you need to do. And then you're going to record your results. So after you record your results, you need to ask these questions. What did we compare in this investigation? So who knows what we compared in the investigation? You can pick your hand up or you can type it in the chat. Policeware, your hand is up. You can unmute yourself.
Hello?
Hi.
Oh, I raised my hand because I wanted to say the answer of the salt dissolve faster on cold water or hot water.
Okay, very good. But you answered my question now, which is what did we compare in this investigation? We compared how salt dissolves in hot water, cold water, and tap water. Okay, who Oh, Bishle, I'm very happy that you attend the club. So you're going to be one of the future scientists that's going to um, uh, become a great inventor later on in life.
Thank you, ma'am.
Srisha, this is the lesson your teacher, your previous teacher, which was yesterday, prepared. So I'm doing his lesson for you. Okay. So we're going to continue. Oh, yeah, this next question. Now name three things that were the same about the three situations. So what was the same? Who knows what was the same? In all three situations, what was the same? For Bushle, your hand is raised. Okay, Hermione answered correct. Very good, Shakira. Yes.
Could you please repeat the question?
The question is, name three things that were the same in all three situations.
I think the granules.
Okay, the amount of salt, that's one, very good. Michael, the last teacher I presume you're talking about was the Mashangai, which is, so you probably did this with her, and the reason why we're doing it now is because we following the revised CAPS curriculum, which the government has asked us to do. Now, because we were on online schooling, we did the whole of term 2 syllabus, right? Which is not now required because schools were closed, but online school was open. So we did the whole of term 2 syllabus. So now what we're doing is we are doing the revised CAPS curriculum. And part of this means that we have to do these again. And this is what you're going to get tested on when you're going to do exams. Okay, I hope that answered your question. Lebo, your hand is up. You can tell me the other ingredients.
The amount of
The amount of water, very good. Sorry. The amount of water, well done, Lebo. Okay, so one is the salt, that stayed the same, the amount of water. Then what's the next one? Okay, thank you, Tricia. So what's the next one? The next one is the size of the cup. Okay, so we measured the temperature of water. Okay, what else did we measure? We measured the temperature of the water. So we recorded the temperature of the water in hot water, cold water, and ice water. So there were three different temperatures of the water that we recorded, the time that was used to dissolve the solution. Now, in which situation did the salt dissolve the fastest? I know you know the answer because you told me in the previous slide. So who wants to give me that answer again? Very good. Hermione and Ocean, well done. Okay, Lebo, you can unmute yourself. Well done, Tricia. Well done, Shakira. You all have the correct answer. Talia, well done. You want to give me the answer?
Yes, ma'am. The answer is hot water.
Okay, well done. I'm very proud of you. Everyone that answered correctly, I'm very, very proud of you. When we're young, especially at this age for the CWA, most of us don't know what we're going to become when we grow up. It's only when we experience life and we decide we become passionate about something and we decide what we want to become. So don't stress about if you don't know what you want to become when you grow up older, don't stress about it now. Okay, when you find something that you're happy about and passionate about, then you can do it later. Well done, Shakira. I'm very proud of you. That's the way to go in the future. Now, so conclusion of this experiment is the salt particles dissolve faster in the hot water than the cold water, and the temperature affects the rate of dissolving. And when we increase the temperature of the solvent, the rate at which the solute dissolves is faster. Okay, so I'm going to repeat this one more time. I'm glad you love science, Ocean. Okay, so now let's not talk about what we want to become when we grow up. Let's focus on the investigation and the results of the investigation. So we concluded that salt particles dissolve faster in hot water than cold water, and temperature affects the rate of dissolving. And when we increase the temperature of the solvent, the rate at which the solute dissolves is faster. Okay, so I just wanted to show you one thing before I move to the next investigation. So when we did our investigation, we found that we needed an aim. So we got the aim, and we needed materials and apparatus. We got our materials and apparatus, we needed a method. So we did the method, we followed the method, then we asked questions based on our observations and what we recorded. And after we followed our asked questions and did our observations, we derived at a conclusion. And that is how you conduct an experiment. Okay. The salt in hot water is faster. You're very good, Tricia. Lebo, which slide do you want me to go back to? You can unmute yourself and tell me. Or you can raise your hand and I will unmute you. So, okay, I'll go through it slowly. So it was the aim first that we need to do. So we write down our aim. After our aim, we write down the materials and the apparatus. After the materials and the apparatus, we write down the method. When we finished with the method, we prepare questions based on our observations, and we record the information and we derive at a conclusion. Okay, so now we finished that experiment and we can continue with the investigation 2, which is the size of the grains. Now in this investigation, we will determine which dissolves faster. So it would either be coarse salt or fine salt. So you could look here. Now this is fine salt in this beaker, and in this beaker we have coarse salt. Coarse salt is also rough salt. So which, and now you can see we're stirring. And Lori, you can unmute yourself. You could tell me which do you think is faster, coarse salt or fine salt?
Ma'am, I think the one that's I know the one that's faster is the fine salt, because it's smaller, so it will break up and distribute evenly faster than the beaker with coarse salt can break up.
Very good, well done. Okay, because it's smaller, so it's going to be the fine salt with the one that's going to break up. Okay, and in the chat we're going to see who wrote the answers. Okay, so we're talking about the size of the grain, which is fine salt and coarse salt.
Yes.
Now we need our materials and apparatus. So your materials is 2 glass containers. Then you needed fine table salt. Then you also needed coarse or rough salt. Now coarse or rough salt they mostly use when we cook. Then you need a teaspoon, that would be 5 millimeters. Each teaspoon has a measurement, and the standard measurement of a teaspoon is 5 ml. Then you need tap water. Okay, so both beakers would have tap water because we're not measuring temperature, we're measuring the size of the grain. And you need your stopwatch. So you're going to stir it. Now you're going to pour the same quantity, which is 100 millimeters. Then you're going to use 1 teaspoon of fine table salt and in one beaker, and then 1 teaspoon of, sorry about that, 1 teaspoon of fine table salt in the second beaker. And you're going to stir the solution and measure the time it takes to dissolve. So you're going to stir the first solution with the fine salt, and then you're going to stir the second solution with the rough salt, which is the coarse salt, and you're going to record the time. And does the same do, and you're going to do the same for the rough salt. And you're going to answer your questions. Did we compare what did we compare in the investigation? So we compared the rate of dissolving of the grains of fine salt as compared to coarse salt in tap water. And the 3 ingredients that were the same was the size of the beaker, the amount of water, and the amount of salt that we used. So what did we measure? We measured the salt and we measured the water. So what type of salt dissolved faster? So we had the answer said already. So it was the fine salt that dissolved faster. And what complete the conclusion by filling out the missing words in the next sentence, in this slide over here. So our conclusion would be, okay, Ocean, I'll go back to the method. Let's just go to the conclusion just now first, right? So our conclusion would be the fine salt dissolved quicker than the coarse salt, and the grain size affects the rate of dissolving. When we increase the grain size of the solute, the rate at which it dissolves is faster. So for Ocean, I'm just going to go back to the method. I think she wants to write it down. Okay, so you're going to pour the same quantity, which is 100 millimeters of tap water, in each of these clear containers. And you're going to take 1 teaspoon, which is 5 ml of fine table salt, and you're going to put it in this glass. And then you're going to take 5 ml of rough salt and put it in this glass. And then you're going to stir this solution first, and you're going to see if it is faster or quicker. And then you're going to record the amount of time. And then you're going to stir the one with the coarse salt, and you're going to record the amount of time. Okay. So basically our lesson is going to end now in 2 minutes. So in this 2 minutes, let's see if I can do stirring quickly for you. So the aim, this investigation helps us to determine whether stirring increases the rate at which a solution dissolves. So now we have a solution here. We put salt particles at the bottom, and we have the beaker, and we have our stirring. Sorry. Okay, so we have materials and apparatus. You're going to list what I'm going to ask you to mute yourself. We don't want talking in the class. Okay, so whoever is right, you muted. So I'm going to continue. Okay, for those learners that need to go, you're welcome to go. Okay, but we do have 1 minute left. So now, what method will you use for this investigation? So you're going to use stirring. Okay, what did we compare in this investigation? We compared the rate of stirring in a liquid. And what made the salt dissolve faster? So was it stirring or non-stirring? So in the first beaker, we did not stir, and in the second beaker, we stirred, and that we found that when we stir a solution, then it dissolves quicker than when we did not stir. So what did you learn from the lesson today? You learned basically that temperature, the higher the temperature, the faster the solute dissolves. Okay, so the rate of dissolving increases with higher temperature. Then you learned that the rate of stirring is faster. So So the solute dissolves faster when you stir it, and the size of the particles, the smaller the particles, then the solution, it dissolves faster. So information from this was derived from this website here. And thank you for joining me. Your teacher will see you on Monday. I had a lovely time teaching you today. I hope you did. Bye, everyone. Have a lovely weekend. Bye, and your teacher will see you on Monday.